So let us discuss this example of metric. Okay, so already many examples we have seen of metric. What we have to do? Simply we have to prove that D, okay, whatever the D is given, we have to prove that it satisfies 4 properties. So here they have defined D in this way, little bit complicated, but don't worry, we will prove. We'll prove that it satisfies all 4 properties. So that's why we can declare it is a metric on X. Okay, so what we have, D is a metric on R, we have to prove. So shall we start? Okay, see, I will directly start with first property. So for if you take any two elements of R, okay, if you take any two elements and if you take their mods, definitely mod will be greater than or equal to 0. Okay, so see, so yeah, so mod X is greater than or equal to 0 and mod Y is also greater than or equal to 0. So both of them are non-negative. If you add, again the number will be non-negative. So that's why, so mod X plus mod Y greater than or equal to 0. See, mod X plus mod Y is D of XY, right? So D of XY has two different definitions. Either it will be 0 or it will be this one. It is 0, no need to worry. 0 means it is not a negative number, and this is also greater than or equal to 0. That means in both cases, our D of xy is greater than or equal to 0. I will mention by definition of D. Okay, so in both cases we have got it is greater than or equal to 0. So in this way we proved our D satisfies the first property. So let us go for second property. What is the second property? Second property, that means D of xy is equal to 0 if and only if x is equal to y. Okay, so if you don't know, I will write here. Second property is D of xy is equal to 0 if and only if x is equal to y. This is the second property. So let us start to prove. See, keep in mind one thing. So when our given D has two distinct definitions, then we cannot do it directly. Okay, if you have, it has only one definition, then directly we can solve if and only if and only if and only if we get the answer. But see, if the given D has two distinct definitions, so there we have some another method to prove the second property. So what is that second another method? I will show you. First, if I will consider x is equal to y. See, if x is equal to y, definition says if x is equal to y, value of D of xy is 0. So if x is equal to y, we get D of xy is equal to 0 by definition. Okay, and if x is not equal to y, let us see what will happen. If x is not equal to y, obviously we have a second definition. So D of xy, which is equal to mod x plus mod y, right, by second definition. I will remove this part since we want some more space to write. See, mod cannot be negative. That means either we will have 0, either we will have 0 or greater than 0. But see, if you have 0 here, suppose if you have 0, that means x and y both of them are 0, then only you will have 0, right? So, but x and y both of them are 0, that means x is equal to y. But here we are saying x is not equal to y. You are getting my point? What I am saying? Okay, what I am saying, so we have two possibilities, either it is greater than equal to 0 or greater than 0. Let it possible, if x is equal, this is equal to 0, then both of them should be 0. That means both of them are equal, and it is not a part of this case. So that's why we have only option is it is greater than 0. Okay, so see what I want to say, if that means D of xy is not equal to 0. Greater than 0, that means basically it is not 0. That means if x is equal to y, then only we are getting 0. And if x is not equal to y, we are not getting it is equal to 0. So that's why I can declare. So therefore, or I will clearly mention, therefore D of xy is equal to 0 if and only if x is equal to y. So in this way we proved second property also. So make a screenshot of it, and after that we'll go for a third property. Okay. Okay. See, let us go for the third property. What is the third property? Third property is D of xy is equal to D of yx we have to prove. Okay. See, what will I do? I will take two elements for x, y belongs to R. What will I do? I will discuss two cases. The first case is x is equal to y, and obviously the second case is x is not equal to y. So in both cases we will prove we are getting this one. Okay, so see, when we have a, that means if the given definition is like this, equal to x is equal to y, x is not, 2 or 3 definitions, then we have to follow this method. We have to discuss several cases. So let us discuss those cases. So first case, if x is equal to y. See, if x and y, both of them are same, what will happen? The definition says d of xy is 0, right? And if you think about d of yx, that is also 0, since both of them are same. X is equal to y, that is nothing but y is equal to x. So that means d of xy is 0 and d of yx is also 0. So that means we can write d of xy is equal to d of yx. That means in first case, okay, we proved that d of xy is equal to d of yx. So let us go for the second case. So what will be the second case if x is not equal to y? Okay, then see, let us see what will happen. I will start with d of xy. I am considering x is not equal to y. Okay, so then d of xy is equal to, okay, I will remove this part since I have to write some things here. So d of xy is equal to, yeah, x is not equal to y, that means obviously I should go for the second definition, and the second definition says it is mod x plus mod y. Tell me 2 plus 3. 2 plus 3 is same as 3 plus 2, obviously. So therefore this is also nothing but mod y plus mod x, right? And this is nothing but d of yx. So we started with d of xy and we got d of yx. So that means in both cases we are getting d of xy is equal to d of yx. Therefore, from above two cases we get d of xy is equal to d of yx, and this is true for all xy belongs to R, right? So that means in this way we proved the third property also. Okay, only we have to prove the last property. Make a screenshot of it and after that we'll go for the last property of this example. Okay, so let us go for the last condition. Last condition is known as triangle inequality. So in triangle inequality, 3 elements are required, and that d of xz less than or equal to d of xy plus d of yz. This thing we have to prove. Okay, but to prove this one I have to consider several cases. Okay, so let us discuss all those cases one by one. I think I have already written 3 elements I have already taken. Okay, so my first condition is all 3 elements are equal. Okay, so the case 1, okay, case 1, so x is equal to y is equal to z. See what will happen if I consider all 3 elements are equal. If they are equal, so therefore d of xz is 0, right? D of xy is 0 and d of yz, that is also 0 since all of them are equal. So therefore d of xz I can write is equal to d of xy plus d of yz, since both of them are 0. So sum is 0 and left hand side is already 0, we know. So that means we get an equality here. That triangle inequality we are proving actually, but here we get in this case we get an equality. So let us go for the second case. Can you guess the second case? So the second case is obviously, what will I do? I will consider x is equal to y, but y is not equal to z. That means these 2 elements are equal, but they are not similar to z. So in this case what will happen? Therefore, see, x and y are equal, so d of xy is 0, no doubt, getting, and d of xz is same as d of yz. Tell me why? Since x and y are same now, so that means if first x is same as y, both of them are same, so and just last component is different, so that's why it is possible. Okay, so because the reason is, I will write here, the reason is because x is equal to z, x is equal to y, right? So this is equal to 0 plus d of yz. Maybe you will think that I am adding 0. If you add 0, you will have same thing, getting? So why I am adding 0? Since 0 is a value of d of xy. So this is equal to d of xy plus d of yz, right? So therefore d of xz, okay, d of xz left hand side, and is equal to d of xy plus d of yz. That means again we get equality, right? So let us go for the third case. What will be the third case? Case number 3. Can you tell me the third case? This time I will consider x and y are unequal, but y same as z. Okay, so let us go for the third case. X and y, these are two distinct, but y and z are same. So therefore, what can I write? D of yz is equal to 0, since both of them are same, and d of xz is equal to d of xy. Agree with me? Since z is same as y, no, z is same as y, so d of xz is same as d of xy, right? So this is equal to d of xy plus 0. I am adding 0 simply. If you add 0, you will have a same term. But 0 is the value of d of x, y, z. So therefore, d of xy plus 0 is nothing but d of yz. So therefore, what we get, d of xz is equal to d of xy plus d of yz. Again, we get equality. So that means all these three cases we are getting equality. So let us go for the last case. So it's not last. Let us see how many cases will be possible. But the next case will be, can you tell me? We have considered all of them are same. We have considered first two are same, last is different. We have considered first is different, last two are same. And the next case will be obviously first and last are same and the middle one is different, y is different. So obviously, so therefore, d of xz is equal to 0 since these two are equal, right? And d of, see what will happen, d of xy, just a minute, d of xy is greater than 0 and d of yz, that is also greater than 0. I am saying it is greater than 0 since these two are distinct. If these two are distinct, obviously we will have some greater than value. If same, then only we will have 0, otherwise we don't have 0. So that's why both of them are greater than 0. So if you add, so these are positive, xy plus d of yz. This one is positive, this one also positive. So if you add two positive numbers, again you will have a positive number. Okay, so the same thing I will write in a different way. 0 I will take on this side. 0 less than d of xy plus d of yz, right? But 0 is nothing but d of xz. So therefore, d of xz is less than d of xy plus d of yz. Getting? So d of, here we get inequality, here we have got equality, here we have got equality, here also we get equality, but in this case we get inequality. So all cases are covered, or still you think some cases are remaining? All of them are equal, first and second are equal, last is different, first is different, last two are same, next first and last are same, middle one is different. Obviously one more case will be there, that is all three elements are distinct, all of them are different. Okay, just one more case is remaining. What will I do? Make a screenshot of it and after that we will go for the last case. Okay, so let us discuss last condition, that is all of them are distinct. Okay, so what will I do? I will start with d of xz, right? D of xz is equal to, what can I write? D of xz is equal to, see, x and z are distinct, so I should follow this definition, mod x plus mod z. So if you add one more, okay, two more elements, what will happen? You will have less than or equal to mod x plus mod y plus mod y plus mod z. I have added this mod y. Okay, so if it is 0, we will have equality, and if it is not 0, we will have definitely positive number, we will have inequality. See, but mod x plus mod y, that is nothing but d of xy, right? So d of xy, and mod y plus mod z, that is nothing but d of yz. So see, so here also we get inequality. Okay, should less than or equal to. So that means what is our conclusion if you consider all 5 cases? So therefore, from all above cases, what we get from all above cases? We get d of xz is less than or equal to d of xy plus d of yz for all xyz belongs to R. That means in few cases we get equality, in few cases we get inequality. So finally we combine all these things and we get less than or equal to. So in this way our D satisfies the last property also. Already here it has proved, we have proved it that it satisfies first 3 properties. Now we prove it satisfies the last property. So therefore we can declare, therefore D satisfies all properties. Therefore D satisfies all properties. So therefore what is our conclusion? Our conclusion is, therefore D is metric on R. So you can make a screenshot of it. Problem is over here. Okay, and thank you. Bye.